Hi everybody, one final set of slides. Final project. I want to make 2 points and I'm going to go over these throughout the next few slides. Number one, the assignment and the whole course is not about analysis or a really highly functioning research project. This is about presenting the data. I want you to spend all your time from now to when you submit the final project working on the presentation of the data. Make a story with what you have. Don't make more stuff. You don't need to analyze or statistically calculate or demonstrate or look for causation or explanation. Stop. Make a beautiful graphic with what you have. Okay, that's the first point. The second point is get outside of the traditional scientific plot box. Okay. First of all, I don't want to see anything that looks like a default setting, right? I want you to change the proportions of all your plots so that the labels and the marks have a distinctly different look than any default setting that would ever come out of Excel or Tableau or ArcGIS. I want you to change or remove the plot titles. Don't describe the data, don't describe the axes. Summarize the plot. Ask a question about the plot that the plot answers, and then answer the question. I want you to tell your audience what they should be taking away. Don't just describe what the axes are or the time range or whatever it is. Okay, I'm going to show you a bunch of examples of this. We're going to start with some examples about Arctic sea ice volume. So this is a really classically scientific presentation of Arctic sea ice volume. Time is encoded on the X. Volume of ice is encoded on the y-axis. The loss of ice volume is in red over time. The maximum volume is mapped in blue. And then the length of the gray bar in between is encoding the volume difference between the max and the loss values. This has really high data density. There's a lot going on here. The title is literally describing the variables encoded and nothing more. And I just want you to think about how many ways there are to tell the story of Arctic sea ice volume loss over time. Some good, some bad, some data dense, some emotional. Here's a plot that does just about everything we talked about not doing in a data visualization. This is a very editorial piece of quote unquote data viz, or you know what I mean. So we're using 3D effect, changing perspective. We've got the employment of chart junk, like this tablecloth looking random map of someplace that isn't even the Arctic. I mean, what were they thinking? But if we take this as two completely separate visualizations, the ice cubes are, a way of showing a decrease in volume because they are technically a volume and they're ice. We don't have any context for what these numbers mean over time. Oh, wait, that's what this is. So 1979 to 2012, we can see that there is, a decrease in volume over time. So it's trying, right? It's just doing a lot of things that, we have talked about not doing, but maybe it could be argued that in a way it's catchy and might get people to look at it. I'm not sure how I feel about the y-axis being dual labeled. Okay, we have animations and satellite imagery. We have artwork. This is an artist named Jill Pelto who plots things like sea ice, volume change, increase of forest fire. She's got a lot of art that she just then watercolors and kind of makes look interesting. This is something called a radial plot. Time is encoded on the x-axis, which is wrapping around. That's the circumference of the plot. And then volume is on the y-axis, and those are the spokes of the wheel coming out. Each one of these is a y-axis. So it's kind of cool. The color scheme, we've talked about rainbow, and we've got this luminosity issue here, and again here, which is not good. But at least it does color-wise wrap around back on itself, right? Because it's cyclic. Unfortunately, these aren't wrapping around to themselves, so that doesn't work very well. But, nice try. Yeah, so basically over time going, it's basically showing that the volume is decreasing like this. Not a very efficient way. This one is the same exact idea. Volume is again encoded on the Y, but it's drawn in a square, which makes it look like a Cartesian plot, but it's not. So color is encoding time. The time of year is on the x-axis. You just can't see it, other than the fact that they've got spring and autumn for the northern hemisphere labeled here. So it starts in 1979, and then we're using this is our y-axis as the spokes going out like this, and volume is decreasing, decreasing, decreasing. Here they've just connected, you know, the end of one year to the beginning of another year. And when you look at this thing in 3D, the web is calling this the spiral, the death spiral of Arctic ice volume. So I'm showing you all these different kind of plots as a last-ditch effort just to get you thinking creatively about how you can display quantitative data in really unique and novel and informative ways. So as you leave this course and go on to other courses or to your work or research projects, keep pushing yourself to find creative and novel or unique ways to show your numbers. And please, I mean, if nothing else, just don't use default settings. Be more deliberate. Okay, oh dear, sorry about that. All right, so let's just take a look at this guy here, reining things back in and focus. Decode this plot really quick. It's ice volume over time. What do you think the takeaway message is? We've got a title, Daily Arctic Ice Volume. We can see that we've got 8 years that are plotted specifically against a mean over, what, a 30, 40-year time period. And we can see that each one of these years is significantly below the mean for this larger period of time. We can also see that the data visualizer chose categorical colors for sequential values. Ugh, please don't do this. So that was bad. But we have to do all this work. We're going to read the axes. We're going to figure out that volume is on the Y and time is on the X, and we're going to look for these comparisons and make the inferences ourselves and compare that with the exact same data set. Same thing, we're still talking about sea ice volume, but this was a plot made by a guy named Derek Watkins for the New York Times. The title is Arctic Ice Reaches a Low Winter Maximum. This is what I mean by summarize the plot. Tell us what the plot is about, not just describing the variables. This is Arctic sea ice volume over time. Boring. This is actually telling us that in 2012, the Arctic ice extent reached the lowest point on record. Hey, that's the title. It's using annotations to walk us through. It's using color really carefully. They're using color as a legend. Hey, this thing tells us what's going on with these lines. We've got these subtle additions that help us see when winter and summer and winter is. That helps us make sense of the pattern that we're seeing. And then everything's summed up with some interesting tidbits of information in here for us. On the y-axis, yeah, we could just have 18 million square miles or square kilometers, but put that in context for us. Right here, 10, that's how big Canada is. Right here, that's how big Alaska is. This is really helpful information, right? This makes it human, it makes it relatable. The visualizer is telling me exactly what he wants me to see. I feel oriented, I understand each element, I don't have to wonder, right? It gives me a sense of where I'm supposed to look and when. My eye isn't having to travel around from one thing to the next to look for legends and things like that. It just feels very clear. I understand what's going on because Derek Watkins told me over and over again what I'm looking at and what I'm supposed to be looking at. This, if you can do this, you're golden. Okay, so a classic bar plot, you guys are going to be making things like this. But look at just the small changes that take this from your default bar plot to something that's novel. They moved the y-axis and staggered it so that the numbers are kind of where they should be to make sense. They could have moved it over to the right, and you guys can certainly do that. but that would compete with the labels for this bar. This is just slick. It's all stuff that you know how to do. It's just being creative enough to think about it, or doing some digging online and just getting inspired by things you've seen. Giving context here. Labeling things directly. Here we're kind of combining multiple, what could be told in multiple plots by just sticking it all together in one plot. I want you to think about the relative proportion between the marks and the text. Look at how exaggerated this is relative to default settings that come out of anything, Excel or Tableau. The marks are tiny compared to the labels. I really want you to keep this in mind. Again, also using annotations to create interest and story in your plot. This is what you guys should be working on this week. Here's just a path from these aren't even really default settings, because these numbers and labels have already been blown up quite a bit. I mean, the bars are way too big, but whatever. It is what it is. But here we're kind of increasing that text hierarchy a little bit and creating a bold title and a subtitle, and then cleaning things up and pushing things into the background, using color, bolding, changing to gray on white instead of black and white, right? We could keep going and make better plots. Like, do we really need the word region on there? This could be done a lot better, but this is what I'm talking about. You guys push it this week, clean things up, get away from the defaults. Here, this could be titled survey results, 100% response rate, N of 100, survey about, I don't know, interested and excited about science, something. It could just tell us what these are, but they completely changed it. They summarized it. The pilot program was a success. Here's the question. In gray, acting as a legend, surveyed before they did the program and then after they did the program in blue. So pointing out that, hey, after the program, there was a majority of students, or a larger number of students, that were kind of interested or excited. So walking us through it and summarizing it. The data almost plays a supportive role in that we can look at this for the context that we're looking for, or for details, but the story is being told to us in the way it's laid out. Okay, a lot of you have created these kind of tree plots. I just throw this in there because it's really nicely done. Labeling things in the middle, kind of diverging x-axis, or y if you want to think about it that way, but diverging out, use of color, simple legend, labeling things directly so your eye isn't hopping back and forth. Yeah, just nicely done. Okay, so let's talk about putting it all together. I want you to tell us a story about your data using the plots you've made or the map that you've made, and simple, bold annotations and titles to kind of move us through the page. I realize that some of you are making graphics, some of you are making interactive dashboards. I've seen story maps. There are a lot of different outputs that are coming. That's fine. This same principles apply. Summarize your plots in large text blocks that can serve as titles, but again, not descriptions, but summaries. What's interesting? What's the interesting takeaway? What's the question that's going to make us care about the plot? And then where do we find the answer? Okay, use arrows, use text grouping, use outlines, color blocks to pull us from element to element. And this is kind of an interesting one to start with, because there's 4 basic information blocks, or maybe 5. There's this opening, title. Then there's this opening thing that's just a summary, right? These are just random statistics. There's no graphic here, but why can't you do that? You can. It's also acting as a legend. A simple map. Notice that we don't have latitude and longitude lines. We don't need ocean. This is considered a thematic map because it's not about actual locations. It doesn't matter where the cities are. It doesn't matter where mountains are. We're just looking at spatial distribution on a globe of these, whatever these are. Really simple graphics, and then a summary here. So what you need to work on this week is making sure you unify the relative sizes of the plots based on their data density. How much overall information is the plot or the map presenting relative to everything else? This isn't perfectly dialed in, but think about it that way. How much of the, I guess it would be kind of unifying the intellectual hierarchy with the visual hierarchy, prioritizing things on the page relative to how much information they're conveying, just like you do when you make a map. Make sure that you're unifying the text on the page, making sure that your axis labels are all the same size from plot to plot. Even if one plot is smaller, the axis label still needs to be the same size as the other axis labels, or it looks like you just shrank a plot down. Does that make sense? And then use color carefully. If color represents one thing on one map, make sure it represents that or plot all the way through. This is kind of a good example of that. I think this is relatively well done because the sizes of the axis labels are the same. So it looks like it was deliberately set up on the page. But the colors represent very different things, but they're the exact same set of colors, which might be okay. It's also a little bit weird. Like orange is Central America, and it's also rules of law. So I don't know how I feel about it exactly, but it's definitely not, double thumbs up. A lot of you are doing maps and a plot. Look at the relative size of the map to the plot. You want to size things relative to the level of detail and how much information they're conveying. The map has a ton of detail and context, and the small line plot is supplementary. It's not as data dense as the map. So the relative sizes make good sense, but if you look at the plot by itself, look at how big the labels are relative to the marks. You have to do it that way because to set this up on the page, you want this to be very legible. So that's what I mean by making sure the end piece is unified. Kind of flipping back and forth between good examples and bad examples. This one's just a bad example. We have a lot of data density. The text is difficult to read. I think as a whole, we've got this great big number up here. It's hard to take this in all at once. These labels are too small to really engage us or pull us into each separate piece. Dashboards are tricky to work with. They're hard to engage with, but they definitely need attention to the text that's going to pull us into each pane. This is a very, very simple plot. It's actually really only one plot with some summary statistics down here on different things. It's really a bubble plot, right? The size of the yellow circles hopefully would be proportional to the values that they represent, which they aren't at all. I mean, this would have to be 10 times bigger in area than this one, which it's not. This would have to be 7 times bigger than this one. But if you could get those proportional, which you can do in Tableau, you could use these and create a bubble plot that's actually connected to a real map, not just a weird, boring graphic map, and have this make sense. These could be informational and proportional pop-outs that inform, a spatial distribution that you're showing on a map. It's a cool idea, and that would be more than enough for our final project. I mean, the overall look here is exactly what I'm talking about. It can be this simple. Simple text, a color band, and that's it. Okay, so talking about unity on the page, this is okay. This reads, everything reads really well, I think. The color is interesting because it makes it look like a unified piece, but it's confusing because, again, this tealish green represents the USA. It also represents the Mac operating systems. I'm not even sure what this is, but it's Instagram, Google, and something else. And then here it represents the number of page views. So that's a little tricky. If I see USA like this, I go, oh, this must be talking about the USA, and this must be the USA. So that's where I think you need to be really careful. It can be misleading. And this one is really just pretty gorgeous. We've got a really data-dense scatter plot. The color is consistent throughout, so big states, mid-sized states, and small states. And then I love this. Here's a description of what these plots show, but it's a sentence that walks us through. Small states tend to be more politically stable. Ah, this must be showing political stability. And have lower levels of corruption. Ah, look at that. The hill is lower. So it's teaching us how to read the plot and summarizing the plot for us so that we can just keep moving forward. And smaller states enjoy more political freedom because the freedom rating 1 equals free. Oh yeah, cool. And then we can come up here, but small states have improved less. Okay, it helps us understand how to read these things. This is brilliant. Then, because this is so data dense, my eyes skipped it and I pulled in here. So now I'm starting to understand what the colors are, what's going on, and I can come back in here and start thinking about, the red are small states, medium states, blue, and I can start looking for my own patterns and making my own inferences. And then, oh, I wonder what the author is summarizing for me. This is really well done. It's really proportional. Here they're just kind of mapping it out for us, but it's really small because it's basically just showing us the spatial distribution of small, medium, and large, quote unquote, states. Yeah, this is beautiful. If you guys have questions, please let me know, let Jessie know. This is the final push. Again, get out of the defaults, adjust your axis labels and your font sizes, use titles to tell the story and pull us through, and boy, even educate us on how to read your plot. Awesome.